All right, all right, all right. Anybody out there? Anybody got questions? Ready to do this. Do. Oh, we start out slow. Maybe someday I'll have somebody immediately ask me a question as soon as I come on. It's unlikely. Nah. Woohoo, 2 people. My wife hadn't even bothered to show up yet, and she lives with me. Any questions? The one person out there? Might be a short stream. Day 1 for rational functions, 3, 5, and 6. Wow. All right, Tori. Well, that's 3 questions.
Come on, Coco.
All right. Day 1 rational function.
Put a bear.
3, 5, and 6. All right, so let's just dive in. Ready? Ready? Let's do this. All right, number 3. Number 3, we have, I don't know why I wrote 3. It doesn't even have a 3 in it. All right, here we go. We have x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. Okay, so right off the bat, I see that this is not a fraction, so I'm going to write it as a fraction. Just put this over 1. I'm going to look to see if I simplify, but the first thing you have to do is factor everything. The top part here is already, it's in fully factored form. This doesn't factor simply because no combination of multiples of 9 is going to give you 3, so I would just leave it alone because I wrote this problem. I know actually what's going to happen. All right, but this does factor. The x cubed minus 27 is the difference of cubes. So I'm actually going to factor this using the difference of cubes. If you remember, our difference of cubes is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So you have to remember this special factor to factor this one. So I want to get x plus 2 over x minus 3, and then this becomes x squared plus 3x plus 9. It's almost like that was done on purpose. X squared plus 3x plus 9 over 1. All right, so from here, we're going to look. All right, top to bottom, nothing cancels. Top and bottom, nothing cancels. But when we multiply, we're allowed to cancel in the diagonal. So I have an x squared and a 1, nothing cancels there. But I have x minus 3 times x squared plus 3x plus 9, and along the diagonal, it's x squared plus 3x plus 9. This whole thing right here cancels, and this simplifies down to just simply x plus 2 over x minus 3 times 1 over 1. So my final answer would be x plus 2 over x minus 3. Now I want to know the domain. So the domain on this, we're just going to look at the denominators here, and we're going to set each of these not equal to 0 and solve. So we can get x minus 3 does not equal 0, which means x cannot equal 3. And then we have x squared plus 3x plus 9 cannot equal 0. This is going to be complex. You can check real quick by doing the discriminant. The discriminant is going to be your negative, it's your b squared minus 4ac. And if this is a negative number, then you're going to have 2 complex solutions. In fact, it's going to be a complex number because 3 squared is 9 minus 4 times 9 times 1. Well, you can already see right here, this 9 minus 36 is going to be a negative. 9 minus 36 is a negative 25. Right? So at this point, this means it's complex. So this is the only real number that can be in there. So for this, my domain is going to be the set of all x's such that x is an element of the real numbers, and that would exclude these answers because of the real number, and x cannot equal 3. Voila. I think what tripped you up on that one, Tori, is the special factor. Everybody forgets that one. Everybody forgets that special factor. That's why I put it in there. All right, and then 5 and 6. Well, I'm going to pick one. So you pick one of them. I'll explain it. I'm not going to do both of them for you. Which one you want, 5 or 6? You just want me to pick? Because I'll pick the easier one. No, but the Kodacam's working. I'm waiting for her to tell me 5 or 6. Are you posting something in there? All right, number 6. Of course, number 6. You picked a hard one. Ooh. All right, so we have x squared minus 6x minus 27 all over 2x squared plus 2x divided by x squared minus 14x plus 45 all over x squared. All right, so before we do anything, before we try to do division of these rational functions, what we need to do is factor everything. Factor, 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 factor. All right, so right here, the top should factor to, I have an x and an x. Why did I put it so close? Using your finger. Just making things worse. An x, so let's say it's got to be 9 and 3, so minus 9 plus 3. That gives me negative 27 and negative 6. The bottom's got a 2x in common, so I'm going to have a 2x, and that leaves me x plus 1. And then divide by, this is what, 9 and 5. Yep. This factors to x minus 9, x minus 5. This gives me my positive 45, my negative 14. Over my x squared. Okay, everything's factored now. At this point, I want to actually find some terms I need to throw out that I have to figure out some domain restriction. I know that x cannot equal 0 because if I set 2x equals 0 to 0, well, 2x equals 0, x is going to be 0. X cannot be negative 1 because x plus 1 cannot equal 0, it would be negative 1. And of course, then the 0 is already taken care of here. So we already know that this has to be out of my domain. Now, the rule is when you divide fractions is you're going to keep your first fraction and you're going to change your division to multiplication and you're going to take the reciprocal. You're going to flip the second fraction. So we're going to have x minus 9, x plus 3 all over 2x, x plus 1. That doesn't change. Times, now I'm going to take the reciprocal of this. I want to have x squared over x minus 9, x minus 5. All right. Now, let's look again at my denominators and see if I can add anything to this list. Well, 0 is still good, negative 1 is still good, but hey, look, I can't have a 9 here because that would put a 0. So 9 would have to be excluded, and I can't put a 5 here. So 5 would have to be excluded. So basically, anything that gets on the denominator throughout this process, you have to take out of the domain. All right, now let's look if we cancel. Up and down, anything the same? No. Up and down, anything the same? No. But because we're now multiplying, we can look in the diagonals. I have an x minus 9 and an x minus 9. These cancel. I have an x and I have an x squared. Well, the x squared really means x times x. So there's two x's here. So I get rid of this square and get rid of this x right here. So this simplifies down to just simply x plus 3 over 2 times x plus 1 times x over x minus 5. When we multiply fractions, we go straight across. And that's simply going to give me an answer of x times x plus 3 all over 2 times x plus 1, x minus 5. Now you can clean this up by distributing this if you want and have x squared plus 3x and then FOIL the bottom, but I don't really care. If you can get to this point right here, you're good. So that's 2x plus 1 and x minus 5. Now, what's the domain of this? Well, the domain is still the set of all x's such that x is an element of the real numbers and x cannot equal the numbers that we were finding. These were all the numbers that would have at any time on the denominator made this made the denominator 0. So it cannot be -1, 0, 5, and 9. I always put them from least to greatest just because I was brainwashed in school. That's how my college professor wanted it, but I don't really care as long as you have all the numbers there. All right, and then I'll leave the easy one for you. Number 5 is already easy because it's already factored. What else? What else? What else? Well, there's 5 people already in here now. Well, you're 1, so 4. Oh, I am using purple, even though it looks blue. I was like, why does it look like it's purple on the paper? So have y'all seen the message in Schoology yet? Anybody seen the message in Schoology? Is that what they said? About when we could possibly be going back to school? Because it's been released, I can say it. Sure hope y'all plan on keep doing your work. It's going to be a while till you actually see me live. Like in person, like flesh, even though I'm live right now. Any other questions, guys? They just posted, in fact, the governor here shut the schools down until May 3rd. So early, and May 3rd is a Sunday, so at the earliest, we'd be back at school on May 4th, Star Wars Day. May the 4th be with you.
Also Nala's birthday.
Yeah, I don't care about that. It's Star Wars Day.
It's also Nala.
Yeah, I don't care about that. Day 2, week 3, 1, 2, 3, 4, 5.
No.
Which class? Geometry, Algebra 2? No, I'm not going to answer all 5. I got to at least know which packet to look at. I'm not going to answer all 5 of them. I'm not going to do his whole work for him. Let him be a slacker. Or him, or her. Cool. All right, geometry. Geometry it is. So they said week 2. Week 2. I'm looking. There we go. Week 2, day 3. 1 through 5. No. I'm going to only do one of those and explain it to you, and you can do the other 4. I'm not going to do number 5 because that's kind of special. So your choice, 1 through 4. Once I explain 1 through 4, you should be able to do the other 4. Or one of those. Tell me which one you want. Number 3, all right. Number 3. So number 3 is going to tell us to do a reflection. Well, it gives us an order of transformation. So on this day, I'm actually having you do multiple transformations, and I'm having you do them in a set order. Number 3 here says we want to reflect. That is not how you spell reflect. Reflect over y equals negative x, and that's a y, not an x. All right, and then it tells me I want to go horizontal, left 13. All right, so we want to do this one first and this one second. Now the key is you have to go back to day 2 with all of these original, with these mappings, because the reflect over the y-axis is these mappings. So you would just simply look up for the mapping for this. So my reflect over the y over x, it should be negative y, negative x. Yep, negative y, negative x. All right, so this is my mapping for the reflection over y equals negative x. So let's do a point. I'm not going to do all the points either. You can do one. I'll do one of the points just to illustrate. So I have point E, which is 2, 4. Now, this is that xy. I'm going to map it to this. Negative y, negative x. And that's going to give me my E prime, my pre-image, my image. So all I'm going to do is, my new x value is the y value here. So this tells me go grab the y value 4. This negative means change the sign. So it goes from positive 4 to negative 4. This x, it means it's now my y value. So this tells me go grab my x 2 and change the sign. So that becomes negative 2. So that's step 1. So this is 1. Second one says horizontal left 13. Well, that was back on day 1 of week 2 when we were doing translations. So horizontal is your x. Left means minus, because if you go left from the origin, those are negative numbers. And then 13. And then we didn't do anything to the y. So here's my mapping for this. Now what we're going to do is we're going to take this answer and we're going to start with this. So E prime is negative 4, negative 2. So we're going to take what we finished with and we're going to start with it. And now we're going to use this mapping, the x minus 13, y. And now this is going to be E, no wait for it, double prime, because we did it twice. We're real original in math. And all we're going to do is take this negative 4, plug it in here. Negative 4 minus 13, negative 17. We'll take this negative 2, plug it into y. Well, we didn't do anything to it. We get negative 2, and there's your E prime. You'd have to do it with the other points, and then all the other problems on the sheet are exactly the same. It's just a matter of doing them in the correct order, using your first step answer on your second step, and on number 5, you have 5 of them to do. So you'll have E prime, 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 prime at the end. You'll have 5 primes. So that's how you work this whole day. Not terribly bad, just kind of have to stay organized. What else? What else? What else? Huh?
What do you want for dinner?
I don't know. We didn't pull anything out, did we? I don't know. What do you want? You made what? And that sounds good, but we didn't pull the meat out. You'd have to thaw some meat out. Is it Logan or Tori? Week 2, day 4, number 10. Oh, yay. Some algebra. So we have 7/5 times x minus 9 quantity squared plus 19 equals 158 over 5. All right. So this seems easy enough. All I do is solve for x. So what I'm going to do first is I'm going to always think, and this is how I teach algebra for people who struggle with algebra. Think of PEMDAS. So algebra is PEMDAS backwards, so going this way. So if I'm looking for isolating x, I'm going to start from the bottom of PEMDAS and work my way up, and I'm going to ask myself some questions. All right, so add and subtract. Am I adding and subtracting anything to this x? The answer is yes. I'm adding 19 that's outside the parentheses, because if you notice, the parentheses will be the last thing I do. So everything on the outside of the parentheses we have to do first before we get to the parentheses. So I'm adding a 19, so I need to subtract 19 from both sides. And this is going to give me 7/5 times x minus 9 squared equals, well, 158 over 5 minus 19. Now you have to, when you subtract these, you get a common denominator, which is going to be 5. That means I want to multiply this by 5 over 5, and this over 1, multiply straight across. So I will get 7/5 x minus 9 squared equals 158 over 5 minus, let's see, that's going to be 60 minus 5, 55? No.
19.
No, it's 100 minus 5, so it's 95. 95 over 5 That's easy enough. Now we just subtract by top, so 158 minus 95. So I have 7/5 x minus 9. Notice how I'm getting writing smaller. I always forget I don't have to write so big on this. 7/5 x minus 9 equals, let's see, 158 minus 95. That's going to give me a 63 over 5. That gives me a 3. 15 minus 9 is 6. So yeah, 63 over 5. All right, from here, I'm going to show you a trick. You see this right here, 7/5? Well, let's say we're done with the add subtract. We're going to go to the multiply divide because it's outside the parentheses. This 7/5, if I can get it to the number 1, I'm home free. So I'm actually going to do 2 steps of algebra in 1. I'm actually going to multiply this by the reciprocal, which is actually creating the multiplicative identity. So I want to multiply this by 5 over 7 because 5 over 7 times 7 over 5 is going to be 1. But what I do to one side, I have to do to the other. 5 over 7. Well, all of these cancel, and that just becomes 1, and I have x minus 9 squared. Did I make a boo-boo? I must have made a mistake when I was writing this problem. Off by 1 for it being a perfect square. I got it right here. There's no way it gives me a 4. 19 times 5 is, not that. 19 times 5 is 95. And 158 minus 95 is 63. Yeah.
Did you write the problem though?
Yeah, it's 158. All right, so this gives me x minus 9 squared equals just simply 63 because these 5's cancel out. From here, we're done with multiply divide. We go to my exponent. So I have my exponent here, and what you have to know is that the square root of x squared equals x, and the square root of x squared equals x. The square root of what? Oh, 63 over 7. Yes. Woo! There we go. So this becomes x minus 9 squared. Well, 63 divided by 7 is 9, which is now a perfect square because I knew I wanted to get a perfect square. All right, so now I need to take the square root of both sides. So this is going to give me x minus 9. I'm going to take the square root of all of it squared. Well, that's just simply going to give me the x minus 9. The other side becomes 9, but when I take the square root of the other side, I need to put a plus or minus in front of it. That's just a rule. It's ambiguous. So the square root of 9 becomes 3, so we have plus or minus 3. The x by itself, just simply add 9 to both sides, and I get x equals 9 plus or minus 3. There's 2 different equations here, so we just simply have x equals 9 plus 3 and x equals 9 minus 3. Therefore, by simply adding x equals 12, it's the set of 12 and 6. Done. It's a good problem. I like whoever wrote this. This is a great problem. This is a great problem.
This one was like, why are you freaking out? It's like 63 divided by 7 is 9.
Well, that's a really good problem. I like who wrote it.
What is that going to be?
No idea. It's almost like it was planned out to get a perfect square.
Almost.
Almost.
But then you freaked out and didn't trust yourself.
Didn't trust. I forgot about the 7. I do that all the time. It's fun algebra.
Cody doesn't love me today.
Man, I need to clean this board bad. What other questions? What other questions?
Did I give you the spray?
Huh?
Is that-
Yeah, it's down here. Ow. I need to cut my nails. They're getting long. See them? I won't see you through them. So long. Huh?
Is that it?
No. Just saying they're long. What other questions? What other questions? What other questions?
Next.
Re-put the washi tape on. So what do you want to have for dinner? You said we have to go to Walmart and get milk and orange juice. Want to just order a pizza? Where from?
I don't know.
Papa John's pretty greasy too. Huh?
Your daughter's eating.
Little Caesars. The stuffed crust. Ain't nobody got questions. We're down to 2 people now. You and somebody else. Yep. What, am I down to 105? No, I didn't lose any. Oh. I could. I'll just wait and do it. I'll have to be. I'm probably going to knock out the rest of this, all of next month's lessons. You're welcome, Logan. So, yeah, I'll probably this weekend just knock everything else out. I'll probably conference with the other Algebra 2 person I'm working with. Make sure we're on the same page and just knock everything out. So all the products are created. Or does it do what? It's got a lag. Oh, so it's not, it's just, I got you. That's weird. Any questions? Any questions? Any questions? The SAT, is this for the new SAT or the old SAT? Well, look at all those spots. You see all those spots on the glass?
Yeah, no, I can see.
When I sit there?
I can see them.
Because it darkens up.
Huh? I can see them, but like, on the screen.
Yeah, don't give me no English. Yeah, I brought those up, that other strip of light up home, so if we want to play with the other one, see if it, you know what I mean? Do pi r or d pi? But if you're given the diameter, you just slap a pi on it and you're done.
Keep it for problem.
Guys, y'all have any questions out there? My wife's looking at SAT book to try to give me a problem. What?
On over to you.
What do you mean answer it? Like solve it?
Yes.
What's the problem? One half 2x over 3. I like it like that. Okay.
Times 5.
5 over 6.
Times.
And they tell you to solve it?
Yeah.
Well, that and that go away. that and that go away, that and that go away, that and that go away, that and that go away. This gives me x over 7 done. X over 7y.
Thank you.
Forgot the y.
Yeah.
Super easy. Super duper easy. Find a trig problem in there.
So I'm assuming it goes by heart of math. What if you find one off the internet?
If you don't have any questions about your packet, I mean, I guess if you want to look up math problems, keep in mind I'm rusty at some of the higher level stuff. Oh my goodness. This. I literally opened it to this. I open it to this problem. Y equals G secant squared theta over 2 times V naught squared x squared plus x tan theta plus h. And the reason why I laugh at this is a problem that they have to solve in my pre-cal class on my pre-cal final.
Oh, really?
And yeah, in this case, I give them the bullet drop, which is y. Here, I can show it to you on the review. Oh no, because I'd have to plug my hard drive in. On the semester exam review, other pre-cal teachers omitted it, said it was too hard. I was like, boo, this problem's super easy. I think this one, what does it say? This one says, neglecting air resistance, da 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 da. It tells you what G is. It tells you V naught. It tells you H.
That portion, 20 questions.
Yeah, it must be the old one. Oh, this tells you to find. So, this tells me to find the maximum. This seems fun. This seems fun. So it tells me y equals, it tells me my gravity is negative 32 divided by 2, so I'm going to have negative 16. And then it tells me my V naught is 24 over, let's see, x squared secant squared theta plus x tangent theta, and it tells me my h is 9. Look, it tells me to find the maximum of this function. It tells me to find the maximum of this function. So this is great fun. Y equals, let's reduce this. This is going to reduce to, they both got an 8 in it, negative 2/3 x squared. Secant squared is tangent squared theta plus 1 plus x tangent theta plus 9. Let's do hippity hoppity distributive property. I've got y equals negative 2/3 x squared tangent squared theta plus a negative 2/3 x squared plus x tangent theta plus 9. What do we got? These. Y equals a negative 2/3 x squared. This is how you solve the problem on my semester exam. Tangent squared theta plus Oh no, I grouped it wrong. The x squared should stay out. But yeah, you get the x squared and then you use Pythagorean theorem. Not use quadratic formula.
So after the geometry section, there's the data analysis, statistics, and probability review.
Mm-hmm.
And then that's it.
Really?
Yeah, because it was probability. Numbers divisible. Eight.
Huh?
It says all numbers divisible by both by following.
Least common multiple. So what are the numbers? 4 and 15?
Mm-hmm.
4 and 15. So this is going to be a 2, a 2, a 3, and a 5. And what are the options?
8, 18, 24.
And what does it ask?
All numbers by both. Also.
So 6 would be a 2 and a 3. This would be a 2 and a 2 and a 2. This is a 2, a 3, and a 3. So it's going to be 2, 3, and 5. 6 and 5's 30. Huh. This gives me 6 and 4. Gives me a 2, a 3, a 2, and a 2. 9 and a 5, a 3, and a 3. I would think for them to be divisible, they'd have to have.
So this is explanation.
Uh-huh.
One way to first finding by both.
Which would be 60.
But it's not one such number. By that. So 60 by 6.
No. That's
By
weird that
18.
they're using mod, though. I mean, they have shared factors. I think it. I would have thought it had something to do with the factors. That still doesn't make sense to me the way that's written.
Yeah, it was worded weird. No, figure not drawn to scale.
Y'all have any questions out there? I don't think they got any questions. You want to see why an even plus an even is an even? Even plus an odd is an odd, and an odd plus an odd is an even. Do you want to see why? So, even plus an even is an even. But why? Well, the formula for an even is 2 times some integer, and we're going to call this k sub 1 for an integer. I'm going to add it by a different even, which would be k sub 2, where k sub 1 and k sub 2 are elements of the integers. So this is basically any odd number plus any other odd number. Now, if we add these, we can't because these are different variables. However, there's a GCF, right? So now I have 2 times k sub 1 plus k sub 2. And because if you ever add integers is a closed group. Therefore, k sub 1 plus k sub 2 equals k sub 3, and k sub 3 is an element of the integers because integers is a closed group under addition. So this becomes 2k to the third. That means if I add two different integers, I'm going to get a different. If I add 2 even numbers, I'm going to get a different even number every single time. So that has a little bit of group theory and everything else. This is like a very basic proof. Yeah, you too. So that's how you do the even plus the even, right? This is like number theory. This is like early number theory. Now, an even plus an odd. So we do even plus an odd always gives an odd. But why? It's the same trick. 2k sub 1 plus 2k sub 1. Well, we can do 2. It could be the same number. It doesn't matter. I'm going to do 1 so they're consecutive numbers. Like 2 and 3. And 3 and 4. K sub 1. But now plus 1. This right here is an odd number. This is an even number. K sub 1 is an element of the integers. All right. So now we're going to kind of do the same trick, but I'm going to group them, and I'm going to do 2k sub 1 plus 2k sub 1 plus 1. I'm going to group these. They have a 2k sub 1 plus k sub 1 plus 1, and I can say k sub 1 plus k sub 1, even though it could be 2k sub 1, which is an even number. I'm just going to call it k sub 2, and k sub 2 is an element of the integers because integers are closed under addition, so this has to be an integer. So this becomes 2k sub 2 plus 1, which is a formula for an odd number. So any even plus odd will always give you an odd number. My double bar z. So that is why even plus an odd is always an odd. This honestly, I think it's like day 3 of number theory. It's pretty easy. And then an odd plus an odd is always what? Always, never changes. Same reason. Because my odd would be 2k sub 1 plus 1 plus 2k sub 2 plus 1. Combined like terms, I have 2k sub 1 plus 2k sub 2 plus 1 is 2, right? So multiply all. What do all these have in common? They have a 2, and this gives me k sub 1 plus k sub 2 plus 1, and then k sub 1 plus k sub 2 plus 1, because 1's an integer, is going to equal k sub 3, and k sub 3 is an element of the integers because integers are closed under addition. So this becomes 2k sub 3, and k sub 1 and k sub 2 are element of the integers. Voila. Odd plus an odd is always an even. That's a very basic, rough, this is why type deal. This is more of a show than a prove. Prove would have other words and all this other stuff in there, but kind of cool. Most people know this part, but they don't know this part. If I ask you why is an odd plus an odd ends in even, most people can't answer that. Oh, wow. That just knocked out somebody. That just knocked somebody off of my stream. We went from 3 to 2 that fast. Yeah, I know. Well, there's only like you and one other person. I might be shutting this stream down here. One other person in here. You have a question, or I will shut the stream down. Go do some adulting. Go get what we need from the store and then order a pizza. Watch a movie. Wake up tomorrow, grade papers. start knocking out stuff for next month. Probably have it done by Saturday. And then I'll be bored the rest of the month and complain I'm bored. Yeah, I know. I have to remember to eat. Alright, well, I'm going to shut this stream down. If you have any other questions, I'll be back up at 5 o'clock tomorrow. So until then, see you later.